Hello everyone, N3FJZ here. Okay, well, I want to build my splitter and combiner, and to do that, I need two BN43 7051s. Unfortunately, I have one in a bag, but the other one here is being used on one of my early amps. So what I want to do is take that transformer, or this transformer here, off of this board. And I'm going to try something. I want to try this very small. I forget what this is. I think it's a, let me check. Well, it is a BN43204. Okay, so what I want to do here is make up a version of the output transformer, which is on this board. This was supposed to be a 50-watt self-supported amp where it has its own drivers back here. And this amp, of course, is using the what is that? It's an IRF Z34N. And what I'll do is make a replacement transformer for this one with the blue wire using this smaller core. And this is just an experiment. It probably will get hot, but since I'm not really using this amp, I just didn't want to leave it without a transformer in case I needed to use it for something. So we're going to go ahead and wire up an output transformer using a coax braid and a piece of Teflon wire in the traditional type of transformer. Sometimes you see them using brass tubes. There's another way you could use actually use coax braid as your single turn winding. All right, so let's see what we can do. Okay, here we go. First thing I did was I took a piece of coax braid and passed it through the binocular core, and on the end I opened up the braid in such a way as I can pass a wire through each one of these sides here. Let's see here. Okay. And then I'm going to do something very similar to the other side. And that braid will form what normally would be the brass tubes you see on a lot of the amplifier designs. And the way I'll do that, and I'm going to do this off camera because it does require a little bit of detailed work, but I'm going to just separate the braid, and I'll use this tool and just open up that cavity so it actually is like two tubes. So, okay, all right, got the braid opened up now, where you can see two tubular paths through that braid. So this makes up the one-turn winding. And now what I'll do is pass the Teflon wire through that opening and try to fit 3 turns. I was able to get 3 turns on it without the braid in place. The braid doesn't add much to the inside diameter here. So hopefully I can squeeze in 3 turns of this, I think it's a number 20 Teflon coated wire. And we'll go from there. Okay, the first step I'm going to do is solder a wire here. This makes up the center tap of the one-turn winding. Okay, I think that should do it. Okay, I've measured out the length of wire I need already, so I know how long this is. And if you can see that, I've cut it on like a angle to make a point. It makes it a little easier, both sides, passing it through the braid. So, okay, so what I do is instead of winding 3 turns from one end to the other, I'll fold this in half and pass it through like so. So this would be 1 turn, and I'm starting in this direction, which is the opposite from the center tap, so that when I'm done, 3 turns will have the wires coming out on the other end. So this side will go to the transistors, the drain side, and then that's the center tap, which will go to B+. And forgive my homebrew tripod here, it's not very stable. And of course these ends, this one side will go to ground and the other side will be your 50 ohm output to your low pass filter. So, and of course in a binocular, that's 1 turn when it goes through both holes. So that's 1 turn. And this would be turn 2. And this is a tight fit. And forgive me from going off camera, because I'm not looking at the camera while I'm doing this. And let's see, I had to make a little, all right, there's a gap there, so I should be able to get this wire through there. All right, that's 2 turns. And now for the final turn. Okay. That's all right, that makes 2.5 turns, and this last one we'll make it 3. And let me just open this up a little bit more. Yeah. All right, so I do have a pathway through there. almost there. Okay, I hope you can see most of that. All right, so we got our 3 turns. And the way you can be sure it's 3 is that you'll see there's 3 passes. There's one in the middle there, 2 and 3. All right, so, and this again is experimental. This is kind of tight. The wire just barely fits on here, and normally it wouldn't be this tight, but since this is experimental, there we go. There's our finished output transformer with Teflon wire and using a piece of braid from a coax cable to make the 1-turn link. And the output side is 3 turns. And let me show you on the schematic what that looks like. Okay, so on the schematic, you see on the left here, it's 2 1/2 turns. It's that 1-turn braid, and of course the center tap is where the power would be supplied. And then on the other side is the 3-turn. So in this particular circuit, the FET side of the circuit is, I have it marked there 5.5 ohms, and the output is 50. So it's a 9-to-1 impedance ratio. Okay. And so that's what the finished product looks like. And now I'm going to solder it into the circuit. And again, the goal here was to free up that ferrite binocular block for the combiner that I'm going to make for this amp with its twin, which is over here. And hopefully I can either couple these two together to create 100 watts, or perhaps maybe just a lot of smoke. So, oh, and by the way, this is that's the splitter. Of course, the combiner is just the opposite of that. And let me see if I can bring that over. Okay, this is what that I need to free up that other ferrite block. So this here would be one of the binocular blocks on this side, which is what they call the magic T. It's a combiner. And on this side is the, of course, when you combine the two 50 ohms together, it emerges as 25 ohms. And then you need a way of transforming that 25 ohm impedance back to 50. And this will be the other block, where you're going to have essentially 7 turns with a 5-turn tap, and that will then go back out to 50 ohms. So you'll have amplifier 1. Oop, I know you couldn't see that. Amplifier 2, they're combined together. This 100 ohm resistor provides the normally there would be no difference here, so there would be no current, no RF current flowing through the 100 ohm resistor. The only current you should see through this resistor is the imbalance between these 2 amps. So if this one was slightly more or less than 50, the difference would be burned off on this resistor. However, the recommendation is that the resistor should be at least 25% in wattage of what, I'm not sure if it's both amps combined or one. So I think it's just a 1. So 50 watts you would need at least a 12 watt resistor here if one of the amps were to go down entirely. And what this Magic T does is it isolates, so if one amp were to die, you wouldn't have the power going back into the other amp. Or if there's an imbalance, you wouldn't have the difference flowing into the output of the other amp. The difference would be dissipated through this 100 ohm resistor here. So that's what we'll do. So see, let me remove the original block here, and we'll solder in the one I just made. Okay, the replacement transformer is soldered into the circuit, and you may have noticed that I'm not using the center tap, which is that wire that comes right there off the top of the transformer, only because this particular amp has a it's a bifiller choke, bifilament choke here, right there. That's the one with the red windings right behind the electrolyte capacitor. And on the schematic you can see here, that is the one that shows the 10 turns and center tapped in this particular design. Another way you could use the transformer I just built is to actually use the center tap of that transformer without a choke, without the dual choke, and feed it right through the center. So but this particular amp uses this, so I'm not going to use the center tap since it already has power supplied to the drains of the FETs through that bifiller counterwound choke. Okay, I've soldered the PA with the new transformer into the rig and transferred the low-pass filter, which is here, and it's connected to the bandpass filter. And now what I'm going to do off camera is set the bias on the drivers and on the finals, and I've done that in an earlier video, so I'm not going to cover that here. So let me set that up, and then we're going to see what this little transformer is capable of producing, or what this amp is capable of producing with this smaller output transformer, and just see what happens. Okay, I have the biases adjusted now, so with everything set up, idling with no drive, we got 260 milliamps, and that's just the idle current for both drivers and both finals. And the idling current for the board itself without the bias on, is 8 milliamps. So what we did here is that the two drivers were 25 milliamps each, and the two finals were 100 milliamps each. So now we're going to give it some drive and see what kind of power we can produce. Well, I have the the biases set, and I gave it some drive. And the maximum power I could get was 30 watts, which is probably not surprising. Normally with that larger transformer I was able to get close to 50, but I decided to keep it limited to 20. So there's my 20 watts out with the balance modulator unbalanced to allow the carrier through. And if we go look at the scope here, and then what I'll do is give a little bit of modulation here. N3 FJZ testing. 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 Testing. 1, 2, 3. Let's see. Give it the peak here. Test. 1, 2, 3, 4. Test. All right, so we're getting 20 watts peaks. And I do have a little distortion. Okay, I'm over-modulating a little bit. Let me back that down. 1, 2, 3. 3, 2, 1. Test. Test, test, test. Okay, so our little transformer right there is working for this amp, for a 20 watt amp. And that, of course, and the whole purpose of this whole exercise was to simply free up this other ferrite. I didn't have more than 2, so I should order more of these. So now I'll be able to build my my combiner. Oh, that's the wrong thing. Let's get the right label there. These are BN43 7051s. So I'll include those in another video when I build up my combiner and my splitters, and see if we can combine not this amp, but the one behind it, which is a 50. And couple it to its twin, this twin amp here, which is another 50. And we'll see what we can do. Well, thanks for watching. 7-3, have a great day, and keep building. Build something interesting and put it on the air. N3, FJZ, 7-3, everyone.